Continuing on, when you have a fraction raised to a power, basically this means 3/5 times 3/5, which will equal 9/25. We could have just said 3 squared over 5 squared if we wanted to, applying that exponent to both the numerator and the denominator to get to that 9/25 a little bit more quickly. Now, in problem L, do not get coefficients and exponents mixed up. This becomes 3 to the 4th, which is 81. Then with the exponents, we multiply exponents when we have a power to a power. So 2 times 4 is 8, and 3 times 4 is 12. Notice there were 2 3's inside the original problem. The first one was a coefficient actually getting raised to the 4th power. The second 3 was an exponent, and that's where we applied the property of exponents. Most people have no trouble applying one property at a time, but when we get a bunch of these properties mixed together, that's where we tend to get our wires crossed. So be very careful. On problem M, we need to clean up each parentheses first before we multiply. So I'm going to bring in this outer exponent. Now don't use the word distribution here, because distribution is where you have a number out front getting multiplied by each thing inside. This is a power being applied to everything inside. So 2 out front gets squared to become 4. Then with these exponents that are left, we will multiply powers. 2 times 2 is 4. 3 times 2 is 6, so we'll have y to the 6th. Then negative 3 times itself is positive 9. Notice a negative getting squared is positive. We will then have x to the 2nd, y to the 8th. Now we just have 2 monomials getting multiplied together, so we multiply the coefficients together. 4 times 9 is 36, and we will add exponents, 4 plus 2 to get 6, and 6 plus 8 to get 14. And that will be the simplified expression. For problem N, both the numerator and the denominator have negative exponents, so both are going to be moving from and switching places. So we will have x to the 8th over x to the 4th, which when we subtract is x to the 4th. Now you could have just thought of this as a subtraction problem to begin with and said, oh, same base, minus 4 minus a negative 8, and had minusing a negative, turned this into a plus, and gotten to your x to the 4th that way. I've just found it's more successful to move the expressions from denominator to numerator and vice versa as a first step when simplifying these expressions. For problem O, that 5 to the negative 1st is going to come down to the denominator. We already have a 1. We have a 1 as a placeholder. We already have a 5 down below times another 5, giving us 1/25 as the value for that expression. Problem P and Q are very commonly mistaken. For this first one, we get 1 over 6 to the 2nd, which becomes 1 over 36. Then 6 went down below and had a positive exponent. For problem Q, this is really a negative 1 times 6 to the negative 2nd. That exponent only applies to the 6, not to the negative out front. So we really have a negative 1 placeholder, the 6 squared coming down to the denominator, and this expression is equal to negative 1 over 36. For problem R, we will again consider this to be 3 separate problems. With the coefficients, don't think of that negative 12 saying, oh, move that down to the denominator. That's a property of exponents. This is just a division problem, and we get negative 1/4. Now I won't put the 1 here because we don't usually write the 1's. With the x's, I'm going to have x to the 7th going upstairs and x to the 4th going downstairs, and then I can subtract getting x to the 3rd, which will stay up in the numerator because it's positive. With the y's, the 3 y's come down below, joining the 5, giving you y to the 8th in the denominator, and that would then be the simplified expression. Now let's move on to a more complicated expression. I would first simplify what is inside the parentheses. 3 over 6 reduces to 1/2. I won't write the 1 there, I'll just pretend it's there. With the x's, 2 come down, writing and make this x to the 7th down in the denominator. And with the y's, those 7 come up, and we now have y to the 11th. This is all to the negative third power. Okay, this is where I'm going to not necessarily apply the negative 3 power to each thing inside. Because basically, when each thing inside gets that negative exponent, each thing inside is going to get the ability to move up the stairs or downstairs. So I'm going to apply only the negative here. And applying the negative to each thing inside makes that y to the negative 11th, which moves it down, and 2 to the negative 1st, x to the minus 7th, which move those up. And the net result is I can take the reciprocal of what is inside the parentheses and just raise that now to the positive third power, which then will give me 2 to the third, which is 8, x to the 21st over y to the 33rd power. And these cannot be checked. You have to know your properties correctly and just rework through your work if you want to check it. For this last simplify problem, let's clean up inside each parentheses. In this first one, I can move some u's and w's from numerator to denominator. So the first parentheses will be negative 3w to the 6th over u to the positive third. For this second parentheses, I'm only going to apply the negative. I'm going to move everything down to the denominator, negative 2u squared v to the third w to the second down in the denominator, keep the 1 as a placeholder up above, and only have the third power to work with. I'm not going to change anything in this first parentheses, but I'm going to cube in that second parentheses. 1 cubed is still 1. Negative 2 multiplied by itself 3 times is negative 8. We will then have u to the 6th, v to the 9th, w to the 6th when we multiply exponents together. Now let's multiply these two parentheses together. The numerator will become negative 3w to the 6th. The denominator becomes negative 8u to the 9th when I add exponents, v to the 9th, w to the 6th. I see that my w to the 6ths will cancel each other out in the numerator and denominator, and that my negatives will cancel each other also, and we will have positive 3 over 8u to the 9th, v to the 9th as the simplified form here.